Welcome to Brain Vision.
Our question says that the diameter of the moon is 3,480 kilometers. What is the volume of the moon, and how many moons would be needed to create a volume equal to that of the Earth? Okay, so I went ahead and wrote down what we have given here. We have the diameter of the moon, which I write as d sub m, is equal to 3,480 kilometers. We also know that the radius of the Earth, which you could look up online or is written in the textbook, is 6.38 times 10 to the 6 meters. So the radius of the moon then is also given because the radius of the moon is just equal to the diameter of the moon divided by 2, which is 1,740 kilometers, or 1,740 times 10 to the third meters. That's because, and I'll write this out for visual aid, 1 kilometer is equal to 1 times 10 to the third meters. So that's how I did that conversion to get our radius of the moon written in meters. So then the question is, first, what's the volume of the moon? And then how many of those moons would you need to make up the volume of the Earth? Or essentially, what's the ratio of the volume of the moon to the volume of the Earth? So first, let's find the volume of the moon. The volume of the moon is going to just be equal to the volume of a sphere, where the radius is that of the moon. So 4/3 pi r to the third, where r here is the radius of the moon. So 4/3 pi times the radius of the moon to the third. So if you plug in 1,740 times 10 to the third as your radius of the moon, this comes out to give you a volume of 2.21 times 10 to the 19 cubic meters. Okay. Now let's make that look a little more like a 3. There we go. Let's box that in as our volume of the moon. Okay. So next thing it wants to know is it wants us to find how many moons we would need to create a volume equal to that of the Earth. So essentially, it wants us to find the ratio of the volume of the moon to the volume of the Earth. So we'll go ahead and find this ratio. Volume of the moon, volume of the Earth, again, approximating both of them to be spheres. You have 4/3 pi times the radius of the moon cubed divided by 4/3 pi times the radius of the Earth cubed. Well, the 4/3 pi cancel in both instances, right? And so we're going to be left with the radius of the moon divided by the radius of the Earth cubed. So we'll plug in our radius of the moon, which is 1,740 times 10 to the third meters, right? And we'll divide that by our radius of the Earth, which was 6.38 times 10 to the 6 meters. And we will cube all of that. And that gives us 49.3. So we'll box that in as our solution to how many moons you could fit in the volume of the Earth.